Good morning, everyone, and thank you so much for joining us today. We are delighted to be co-hosting this event with our colleagues at the U.S. Consulate General Osaka-Kobe. Before we begin, I'd like to remind everyone that today's event is on the record and will be recorded. Following the opening remarks and presentation by our keynote speaker, Dr. Bill Mark, we will open up the session for question and answers. We invite you to submit your questions throughout the session in the Q&A box. We will take your questions from there. Additionally, throughout today's program, we will be conducting audience polling, so we encourage you to participate. It will be anonymous. So without further ado, I'd like to introduce my colleague, Jay Biggs, who is the Principal Commercial Officer at the U.S. Commercial Service in Osaka. Jay, over to you.
Good
morning, ladies and gentlemen. I am Jay Biggs, Principal Commercial Officer, U.S. Commercial Services, U.S. Consulate General Osaka-Kobe. Thank you very much for joining us at this webinar. We appreciate that. The embassy, as well as Consulate General and the commercial office, we belong to the Department of Commerce in the United States, and we are promoting the economic relationship between Japan and US, especially science and technology, and the exchange in that area is one of the high priority areas, including Japan. Many other countries are facing the issue of how to transfer the expertise from the skilled workers to the young workers. So we have Dr. Bill Mark to give us the keynote presentation. Now, SRI and us will be co-hosting an event like this in the future. I hope that today's event will be fruitful and it will be helpful to all of you. Thank you.
And now I would like to introduce my colleague, Mr. Yu Ohashi, who is our expert on the advanced technology sector.
Thank you very much for your kind introduction. I am the commercial specialist, U.S. Department of Commerce, Commercial Service Japan. In this department, I'm in charge of the industrial. And in a Q&A session, I will be serving as a moderator as well. So now, without further ado, let's start today's seminar. So I would like to introduce Dr. Mark. And using the AI technology, he has been trying to solve the social issues of shortcomings of the people, as well as to transfer the knowledge to the next generation. So without further ado, Dr. Mark, please take it away.
Thank you very much for the introduction, and good morning, everyone. I'm going to be talking today about using artificial intelligence technology to capture and transfer manufacturing knowledge. But before I get into that, I would like to say just a few words about SRI International to give you some context about where these ideas are coming from. SRI is an independent, mission-driven, nonprofit research and development company. So let me say what those words mean. Nonprofit simply means that we don't have any shareholders. Under United States law, any money that we make, and of course we have to make money like any company, has to go into our mission, which I will be talking about on the next slide. We were started by Stanford in 1946. So next year is our 75th birthday, but we have been independent from Stanford since 1970. And here, independent means that we can work for any client that we want, and we are not biased by having to have allegiance to any particular client. Most of our work is for the United States government, and we also work for companies around the world. We have about 1,500 staff members. As you might expect in a research and development organization, many of them have advanced degrees. And about 500 million US dollars in annual revenue. That, by worldwide standards, that's a small or small to medium size company. But for a research and development company, we're one of the biggest in the world. And that allows us to have the scope to do about $4 billion worth of research over the last 10 years. We have created thousands of patents. We work on at least 1,000 research projects per year. And a very important part of SRI is we're not interested in only doing the research. We want to have impact on the world. And that means that we have to be interested in how the technology is transferred. So in addition to doing the research, or actually as part of doing the research, we create spin-off companies. We license, we have many, many licenses of our technology to companies around the world. And sometimes we build products. These are not going to be large scale products, but very specific products for our clients in the government and the commercial world. Our mission. SRI creates world-changing solutions, making people safer, healthier, and more productive. And I want to stress the word solutions there. Again, we're interested in going beyond doing the research to actually creating solutions that work in the real world. And here are some examples of the many things that we've done. SRIG is one that I'm particularly proud of. SRIG was created in one of my laboratories and became an SRI spin-off company and was later acquired by Apple. Symphony is part of our biosciences group. It's a platform for doing automated drug discovery. It's being applied to COVID-19 right now, among other things. We also created the first humanoid robot that can ride a motorcycle for Yamaha. That's the famous Motobot project. We also have an education group that looks to improve education in the United States and around the world. And we've worked in augmented reality for many years. So if you've ever seen an American football game, those virtual lines that appear on the field to show you the line of scrimmage and the first down line were actually created by SRI. We send our imagers into space. So we're part of the Parker Solar Probe, which is now taking the closest look at the sun ever. And then finally, also from one of my laboratories, we created one of the biggest speech companies in the world, Nuance, which is in the area of speech recognition. So just to give you an idea of the kinds of things we do at SRI. Now, on to the topic of the webinar today, capturing and transferring manufacturing knowledge. So what is the need for this? I think everyone is familiar with this picture. Japan's working age population is declining pretty rapidly, and very important, it's not just that the population is declining, it's that key expertise is leaving the company. And that expertise must be transferred to other employees if we're going to be able to increase productivity, to keep the efficiency and innovativeness of these companies going. So that knowledge has to be transferred to novice trainees and to overseas trainees, anyone who needs the information. Now, it's important to us, we distinguish two different kinds of knowledge that need to be transferred. First is explicit knowledge. That's knowledge that is written or spoken. It's the kind of knowledge that you see in manuals and other documents. It's the kind of information that you see in videos. Then, very importantly, there's also implicit knowledge. Implicit knowledge is what is thought or sensed. And that is something like the sound of a machine. Sometimes experts can tell from the sound of the machine whether things are running well. It can be the feel of a hand tool in their hands. It can also be thoughts about why the expert is doing a particular action. So this is implicit knowledge. Some implicit knowledge can be rendered into words. Some cannot, and we will see some examples of both of those coming up. But it's very important that both the explicit and the implicit knowledge be captured. So this is a big problem. So of course, knowledge is being captured today, and that is primarily in the form of manuals and other documents, videos. There are many instructional videos available, and in-person training, which is a more expensive way to capture and transfer the knowledge, but can be effective. Now, these mechanisms are primarily aimed, in fact, almost exclusively aimed at capturing explicit knowledge. And beyond that, they have some other shortcomings. So for example, they're hard to search, meaning unless you know exactly the words that are in a manual or other document, it's very hard to find information in those documents. And video is notoriously hard to search. And if it's hard to search, that means it's hard to update, because manufacturing processes change all of the time. So finding the exact part of a manual or the exact part of a video that needs to be updated is very challenging. Next, in videos and instructional videos, usually you're seeing a single camera view or maybe two cameras. And that is because human beings have a hard time understanding what's going on in multiple camera views. So that means that it's difficult to see everything that's going on. For example, if the video is showing a machinist, it's very hard to know where the machinist is looking, and it's certainly very hard to know why he's looking there. So these existing methods have some significant shortcomings. Our solution to this is to capture both the explicit and implicit knowledge using sensors. We'll show you that in just a moment. And to use AI technology to take that sensor input and to combine it into an indexed, searchable knowledge base. So the information coming in from the sensors goes through sensor and video analytics, and those AI analytics can map the raw sensor data into the sequence of actions that are happening, where the hand is pointing and whether it's pushing a button, for example, the state of the machine. So the artificial intelligence analytics take the raw sensor data, combine it, and turn it into knowledge that can then be transferred. We augment that with structured interviews and think aloud walkthroughs. So that means that wherever we can, we want the experts to tell us what they're doing. Sometimes that's feasible. Some experts are actually very good at doing that. Sometimes not. So it's not something that we absolutely rely on, but we certainly leverage it when we can. And then finally, we leverage any information that's in existing documents. We use an AI technology called knowledge extraction that automatically looks at documents and creates searchable knowledge nuggets that can be indexed into the knowledge base. So that's the overall form of what we're doing. So here's an example of an instrumented manufacturing environment. You can see that the operator is wearing a head-mounted camera, a chest camera, and also an IMU device on his wrist for getting information about motion. There's a microphone which can capture any speech coming from the operator, but can also be used to get the sound of the machine when that's important. There are Connect devices that enable us to find motion and to correctly find the pose of the operator, how they're standing, where they're pointing. And then finally, we can put sensors on the actual machine to understand more about the machine's state. I'm going to be showing a video in just a few minutes. And as I said before, watching multiple camera views is very challenging for us. So I want to give you an idea of what you will be seeing in the video. We wanted to show you knowledge capture happening in real time, but let me explain first before we get into the video. So what you see in the 4 panels are the information coming from, in this case, the GoPro head camera, the GoPro chest camera, and the 2 Connects. And then this white panel of information here, that is an annotation that we added to show you what the artificial intelligence technology is learning about from these sensors. So in this case, the artificial intelligence technology has decided that what the sensors are saying is that there's an action going on, it's a press action, and the object of that is the front panel forward button. So we'll be seeing this working in real time in just a moment, but this is to give you an idea of what you'll be seeing. Now, to combine the information, as I said, it's important to combine all of the information. We use deep learning based machine vision technology to, for example, detect the objects that are in the scene. We use the connect and vision to detect the pose of the operator. How are they standing? Where are they pointing? Hand detection. We use the text understanding from the manuals, and we use speech recognition and language understanding to understand what the operator is saying. And as we'll see, we need to combine that information in order to capture the knowledge of what's going on in this manufacturing process. So now I'd like to show you a video, which we're going to do transcontinentally. So here you're going to see that exact scene again, except now it will be as
it's going to happen, and it's going to come right about where we are right here, because that's where I've set my reference position. So when we mash the...
So if you could go back just 1 second to get that white thing back up. Yeah, so right there. So you can see here that the system has learned, in this case from the speech, the T that you see there tells us that this information is coming from the text, which in this case is the text that the speech recognition system created from the operator's speech. And it's recording the fact that the operator is saying that he's doing a set action on the reference position. So he's setting the reference position. Again, the AI components put this information together to say that. Okay, you can go on.
Position. So when we mash the button, there we go. So now it's asking me to start the spindle. So we're going to turn this on.
So this is a very interesting example of what I was talking about before. What the operator said was he's going to turn this on. And we would have no idea of what this meant unless we were also getting information from the vision system that says what he's doing is pressing the front panel forward button. So the V that you see here is showing us that this information is coming from the vision system, the press action, the object being the forward panel forward button, and that information needs to be combined with when he said this, that he's going to start this. So this is an example of how this information needs to be combined.
The spindle starts. When I mash the button, I'm going to mash it twice.
So again, this was interesting. The operator used the phrase, mash the button. And the system had never heard the term mash before. By the way, I haven't either. But given the language model that we have, the system could determine that this was actually an action that the operator was talking about, and the action is going to be performed on the button. So the system at this point doesn't know exactly what mash means, but it knows that there was a mash action at this point. And in follow-up interviews or with further data, we can define what mash means.
Because I have a tracking button here. So
again, this is the same idea. He says he has a tracking button here. There's no explanation in his speech of where the tracking button is. So we combine it with the vision information that he's pointing to the front panel screen. So now we know what he's talking about.
When I mash it a second time. The spin.
Okay, and now we wanted to show you an example of implicit knowledge that is extremely hard, perhaps impossible, to put into words. And we chose a very simple example of someone filing a piece of metal. So here we go. So here you see the operator just applying that hand file to that piece of metal. Here he is instrumented. In this case, he's wearing a helmet-mounted, down-facing, wide-view camera. He's wearing a vest that has the portable computer in it. That's just to make sure that he doesn't have to worry about wires all over the place. He's wearing a wristwatch-like device that's measuring his wrist movements. And you can see that there's also instrumentation on the file itself, picking up information from the file. And the kind of information we're picking up, we can stop here, is the force being applied. So this is the force being applied in the fine filing. You saw before the force being applied in the rough filing. In a fuller example, this information would be combined with other information about the pose of the operator and so forth, so that we could actually see how the operator's body was moving with respect to the file, the position of their hand and arm and so forth, which then really helps to convey that information to non-expert people who are going to have to be performing this function. Okay. So hopefully that gave you an idea of how all these pieces fit together. So far, we've been talking almost exclusively about knowledge capture. And obviously, the knowledge that we capture needs to be transferred in order to be useful. So I wanted to say a few words about how we're using artificial intelligence technology for the transfer part as well. So we have the knowledge base now that we've created through the knowledge capture, and we can use that for things like just-in-time training. Because the knowledge is indexed and searchable, we can pull out just the right information that an employee needs to perform their next task. We can also use augmented reality, which again, augmented reality is projecting virtual information onto the real world. So examples in manufacturing would be projecting a schematic, virtual schematic, onto a physical circuit board so that an employee can understand the layout of the circuit at a glance. It could be projecting the names of parts in a complex machine to guide the employee. It could even be things like, you can animate it, so it can be showing which way to turn a knob or a sequence of steps. So this is a very powerful tool for transferring the knowledge. And we found that in real-world manufacturing settings, very commonly the trainees have both hands busy and they're very focused on the virtual reality. So we have found that it is helpful to combine the augmented reality with conversation intelligence. so that the trainee can be asking questions or making comments while looking at the augmented reality. So think here of a system like Siri, except that it can carry on a conversation in a manufacturing setting. So those are things that we're doing for the knowledge transfer part of the job. So the result then is this indexed and searchable knowledge base. You can see that it supports precision search. So if you need to know exactly where the micrometer is being used, it can find the exact place in documentation or the exact place in a video where the micrometer is being used. So that particular segment of knowledge can then not only be found, but can be used in customizable training materials. That could be the just-in-time training that I showed you a little while ago, or training that is customized based on the experience or interests of particular employees. The training can be either offline or online, and the same information can also be used for skills assessment and evaluation, so that we can compare the actions of both implicit and explicit of a novice. We can compare that to the expert to help them learn the skills faster. So in conclusion, I just wanted to point out that the same underlying AI technology can be used for other manufacturing problems as well. So we've used these same AI technologies, not just for knowledge capture, but also to build mobile robots for the factory environment, for anomaly detection or fault detection in machines, and even to aid the design process. So with that, I will come to a close, and I would be very happy to answer any questions that you may have.
Very much indeed for your interesting presentation, Dr. Mark. I'm sure that it was helpful and insightful for all the participants. Now let's go into the Q&A session. From the audience, we received some questions. And I think it refers to one of the examples in the video, the fighting process that was shown. And concerning that, the force, how much force is applied. How do you detect how much force is applied, as you mentioned in the video?
In this case, there is a sensor attached to the file itself, the actual tool, and that is measuring the force as it is applied to the piece of metal.
Thank you very much.
Moving on to next question. So how to capture the technology and how to transfer the technology? The questioner says that he or she is very much interested. However, their manufacturing business is slightly different from the manufacturing flow that you have shown us in the video. So is there how we should be dealing with a recent problem?
Well, so we've actually applied this technology to many manufacturing environments. It is quite general. If you're interested in following up on that, I would suggest that you put that information, that you put that request into the questionnaire that the embassy is going to provide, and we will make sure that somebody follows up with you.
ありがとうございます。
Thank you.
次の質問。
Next question.
先ほどお話しいただいた
In your presentation about the transfer of the know-how or knowledge, how do you transfer the knowledge and information flow? Could you elaborate on the flow of information? How you transfer knowledge?
Yes. So the artificial intelligence technology, I was trying to show an example, but I'll try to be clearer, is recording the sequence of actions that the operator is going through. So it's developing the workflow that it sees, it combines the information from the vision and the speech and so forth, and it creates a workflow. So then there's the question of the best way to train new employees in that workflow. One could be to put them in an augmented reality environment, and as they look at the machine or other tool, they would see step 1, do this, step 2, do this, step 3, do this. And the system can actually check to see whether they properly did step 3. And if they didn't, it will coach them on how to do it correctly and bring them back to step 3 again. So that's one mechanism for doing it.
ありがとうございます。
Thank you
次
very much. And then moving over to next question.
今回ご紹介いただいた事例が工場の
So you shared us with the engineers working in the plant as an example, but the field mechanics,
今回のような技術の
for the field mechanics, is there any efficient way of transferring the knowledge?
Yes, that's a very good question. And I know it's one that, for example, the United States military is very interested in as well, because they have many mechanics in the field. So the answer is yes. Fortunately, these days, the electronics are becoming inexpensive enough that it's quite feasible to have a field mechanic at least have a tablet device or something like that that they can use for augmented reality. So I know sometimes we think of augmented reality systems as very expensive things where people are wearing very expensive goggles and so forth, and that's very good. But it can also be done with much less expensive, easier to handle form factors in the field.
ありがとうございます。
Thank you.
次の質問。
Next question.
こちらの質問に関してはおそらく
Concerning this question,
参加いただいている方
probably we received
ある点かもしれないんですけれども
this question from many,
実際にこう
3 people
情報をいろいろ
or more.
キャプチャーしてお伝えする
Capturing information was mentioned.
この流れの中で
So in this flow of information capture, what about the cybersecurity, the outflow of information? Any countermeasures to prevent the leaking of the information? Any advice?
Yes, what a world we live in, where we always have to be very concerned about the cybersecurity. Certainly, some of the information that will be captured will be proprietary to a company. It might be one of their important trade secrets. And there, I have to say that one of my laboratories is exclusively devoted to cybersecurity research. So I completely understand that this is a problem. I think the ways to handle it would be similar to any other kind of cybersecurity system. We would have to make sure that the actual transmission itself was secure. And then we would have to make sure that all of the connecting pathways, for example, if it's going to be stored in a cloud, that all of those channels are secure as well. So I have to say that there's no magic easy answer, but it's something that definitely needs to be looked at.
貴重なアドバイスありがとうございます。 次の質問に参ります。本日
Moving over to next question.
ご説明いただいたことなんですけれど
So this is what you have mentioned in your presentation. Actually, in the United States, have your solution been implemented in the actual business world in the United States? And if it is okay, can you share the specific case for us so that the people can imagine specifically what you were talking about?
So we have implemented this in real world cases, but as is often true with our clients, we don't have permission yet to talk about any of those implementations. So I'm sorry to give you an unsatisfactory answer, but we're constrained by what our clients want us to do.
例えば産業、インダストリーの情報だけでも教えていただくことは可能ですか？
So
どの
is
よう
it
な
possible just to share with us what kind of industry is using your solution?
I would say big manufacturing is definitely using that. We have, so if the question is specifically around knowledge capture and transfer, I can't think of examples that we're allowed to talk about. In a broader manufacturing sense, we've worked with many companies in Japan, household names.
ありがとうございます。次の質問に参ります。
Next question. So you introduced some cases, examples that was the machining process, manufacturing process. What would be the next step? How or what kind of possibilities are you considering in any particular areas that you can share with us?
Well, we're driven by the needs of our clients. There's a lot of interest in work that goes on in production, manufacturing. Other areas that I think are very important would be assembly. As you know, many of the people in production environments are actually doing assembly. Inspection is another. So all of these are areas of manufacturing and production that we could apply this technology to.
ありがとうございます。
Thank you. The next question. Hold on. So this is a more deep dive question to SRI. The cases that you have shown us today, or the services that you provide, like that related to the technology transfer, I'm sure that it varies case by case, but I just want to know how much cost is needed to implement your technology in the floor.
I think I will defer that to my clients in the Japan office. My suggestion is if you are interested in that, you should put in your questionnaire response that you would like some discussion on that topic. But in general, you're right. We are pretty flexible about how we interact with clients. We have a process that we think works pretty well.
ありがとうございます。
Thank you.
そしたら少し、話がまた戻るんですけれども、
Going back a little bit, earlier you mentioned that capturing the information and transferring it. Probably in EU, there are some concerns. Accumulated data, who owns it? The data policy, data ownership. Do you do that in-house or there might be a difference? Or say that your client, does the client own the data that you capture? Could you talk about the ownership?
Yeah, well, normally, again, this can be changed on a case-by-case basis, but normally one of the values that we offer is that the clients maintain ownership of the data. So that's always something that can be talked about, but you talked also about I think you meant privacy concerns, which also need to be addressed. That is really between the employer and the employee of the company. I have to say, by the way, that I think many, I would hope all, but I will say most employees would see this as very positive. I think the experts really like the idea of their expertise being captured, and the more novice employees really like the fact that they're being given high quality training. So I think it's a very positive thing in the work environment. That doesn't mean that we don't have to worry about privacy, but I do think it's positive.
ありがとうございます。次の質問になる。
Next question about the technology transfer. Well, that the technology itself is changing every day and updated every day. So the model of this technology transfer itself, is that going to be updated on a regular basis?
I'm not completely sure I understand the question. Are you asking about how we, SRI, updates the technology that we use, the AI technology? If that's the question, you're absolutely right, and we do that every day. The field of artificial intelligence is changing at an amazingly rapid rate. We need to stay on top of the latest techniques, and we invent some of the latest techniques, and we always make sure that in our systems we're using the best AI technology possible.
ありがとうございます。
Thank you.
こちらは次の
Now,
質問。
next question.
本社の技術
Your technologies and services. There's a question. Non-English or non-Japanese or Japanese companies have operations and plants in different countries. So do you have an auto translation, or do you also accommodate the kind of minor languages?
Yeah, a very good question. And yes, we're aware that part of the problem is to train employees around the world who are going to be speaking different languages. So yes, we do work in translation. We also use other people's translation software. An interesting thing is, an interesting advantage here is the ability to model very closely the language in a particular manufacturing environment. So I gave you one tiny example in the video where he used this word mash, which is a word that must be familiar in that environment. And we've added that to our language model. So we can do that kind of thing in multiple languages.
ありがとうございます。次の質問に参ります。
Next question. The case, so capturing the various data that you have shared with us, I believe that the one-time capturing of data will not be enough to capture the whole thing. So how much repetition of the capturing needs to take place in order to pile up the enough data, knowledge base?
Yeah, a good question. And it really does depend on the particular environment. Your first statement was absolutely correct. Once is not going to be enough. That would be very rare. So multiple times, but the reason that we put so much effort into the instrumentation and gathering all the possible information is to get as much as possible information out of each time we do the capture. So we don't want to have to go back and find something that we missed. So the answer to your question is yes, multiple times. How many times depends on the actual work being done, but we do try to maximize the information capture for each iteration.
ありがとうございます。次の質問は、先ほどの多言
About the multi-language, it's kind of related to that question. At SRI, of course, you're based in US and you also have an operation in Japan. In other countries, say that we have different projects. Do you have the projects in outside of US or Japan? I'm sure you cannot name the clients, but could you talk about the which area or region that you're operating?
It's actually, these days it's a very difficult question because the companies, including some companies in the United States, actually have their headquarters in Europe and in Asia. So I'll just answer it this way. We have no barriers to working with any country in the world except illegal countries like maybe North Korea. But except for that, we can work with any country, and we've had projects in other areas in Europe and around the world, South America.
ありがとうございます。次の質問に参ります。
Moving over to next question. To capturing the technology. And you have shown us a number of cases, but for the knowledge transfer, can you elaborate on the specific trainings that you are carrying out?
Yeah, so I focused mostly on augmented reality because in many ways that's the most effective. In a manufacturing setting, that's probably what I would recommend. That means creating the virtual information that should be projected onto the physical environment. I think that's actually the fastest way to do it. But we can also combine that with conventional things. So we can create videos out of specific segments that are important for particular trainees to know. So the way the training material is developed really depends on the needs of the company and the students. It's pretty flexible.
ありがとうございます。
Thank you. Next question. If you can answer, it says, the Siri that you developed, well, just like in that example, focusing on the manufacturing using AI, do you plan to have those subsidiaries using your technology in the future? If you can answer to that question.
So again, that's a very hard question to answer. We make decisions about whether something is going to be a spin-off company or licensed to a company based on the dynamics of the marketplace. And we have very specific constraints or goals around spin-off companies. So I really can't answer that directly. It's always a possibility, but right now we're working with other companies.
ありがとうございます。ちょっと待って。
And we have so many questions that we have received, but we have a limited time. So this is going to be the last question to Dr. Mark. And this is a kind of a thing that the people are a little bit worried about. That is the coronavirus pandemic. And that makes the people to work from home and won't be able to advance in their projects they are engaged in. So as an SRI, how are you communicating with the client in trying to advance the project?
Again, this is a very good question for our Japan team, but I will say that we are spending a lot of time. I spend a lot of time, and I'm sure that you in the audience spend a lot of time on conferencing systems like this, talking to our clients. we have found it to be effective to have meetings and to maintain relationships in this distance world. I'm hoping that we can all start meeting in person again very soon, but in the meantime, I think we're being quite effective working at distance.
ありがとうございます。ビラガスたくさんの質問にお答えいただきましてありがとうござ
Thank
い
you
ました。
very much for answering all those many questions. And I would like to hand over the microphone over to Kelsey.
Thank you all so much for joining us today, especially to Dr. Mark and your colleagues at SRI and our colleagues at the U.S. Consulate in Osaka-Kobe. Before we conclude, we have a short event survey that we'd like you as our audience to take. We want to hear your opinions about the event, and the survey does have a place where you can indicate if you'd like further information about today's presentation. So you will see the QR code there on your screen. So again, please take our survey so that we can hear from you for this and future events. We thank you all again so much for joining us today, and we hope that you continue to remain safe and healthy during these uncertain times. Thank you so much, and thank you so much, Dr. Mark.
Thank you. It was a pleasure to be talking to you today.
Wonderful. Thank you and take care.